Awesome.
Made it.
Well, so we've got 11 o'clock on the dot now. We've got all of our panelists here. So why don't we get started? Welcome everyone, and thank you all for joining us today for what should be a really interesting and unique robotic ecosystem discussion. We've got some great panelists from 4 companies that are leading the way in autonomous mobile robot development and scalability. And that's really the central theme for the discussion today, scalability. How can we help more mobile robot deployment succeed and move away from this sort of proof of concept stage that they've been stuck in for many years and into something that's much more meaningful and value driven at scale. I think the last several years have shown us that it's relatively easy to get robots to perform tasks in supervised environments, but it's still proving to be much harder to get robots to perform complex tasks in dynamic environments without supervision. I have a feeling this is going to be a theme we come back to in the discussion today, but I think that's pretty critical to tee up the discussion we're about to have. And accomplishing all of that requires multiple technologies and partners coming together like we are here to create this ecosystem that robots can rely on and thrive on and on their own. And so all of us on this panel have come together today because individually we represent critical pieces of this bigger robotics ecosystem puzzle. That are compatible, that scale well together, and ultimately further enable robots to thrive on their own in these challenging and sometimes unsupervised environments. So with all of that said, we've got a lot of topics to cover over the next hour. I want to dive right in, introduce our panel. Before we do that, just again, the housekeeping notice, we are going to be trying to field questions at the end of the discussion today. Please do put your questions into the question field. We'll have somebody on our team monitoring that. We'll try to get to as many as we can at the end. The questions we don't get a response to today, our team will take those offline. All of us here on the panel will respond to them and send a follow-up email to all the attendees. We're also going to be recording the event. We're going to be annotating everything that we discussed today into kind of a distilled white paper that everyone can have access to after the fact. So without further ado, let's get right into some introductions. Coming to us from New Zealand, the furthest away from all of us is David Ings. He's the CEO of Rocos. They're a cloud platform provider for connecting and monitoring and controlling robot fleets. We've also got Ben Waters. He's the CEO of WiBotic, another local Seattle company here. So nod to you, Ben. They're a provider of some of the most reliable wireless power solutions for aerial, mobile, and aquatic robot systems. Coming to us from Canada, we've got Julian Ware. He's the general manager at Clearpath Robotics. I know a lot of you on this call likely know of them, pretty familiar, but they're a global leader in unmanned vehicle hardware and software. And then finally, we've got Mitch Tolson. He's the director of robotics here at Fresh Consulting, a good friend and colleague of mine, and he leads our brilliant team of robotic solutions integrators here in Seattle. And finally, my name is James Dietrich. I'm the robotic solutions director here at Fresh. And I'll be the one moderating the discussion today. So, all right, well, so let's kick things off. I thought a great place to start would be to open the floor to each of you to maybe talk through some of the key challenges we've all come across when trying to help companies succeed with larger robot deployments. Mitch, I'll maybe start with you. As a robotics integrator, you've seen success and failure take many shapes and forms. What would you characterize as some of the most important things that people should be considering when getting started and thinking about these types of programs?
Sure, absolutely. Happy to be here. Thanks, James. I've learned a lot of things, and I see most commonly that fundamental thing is, and the most impactful thing that you can do to start off any type of project or program like this is really to get clarity on what the problem is that you're solving. And why is that truly the problem? And then the evaluation of those approaches with your team and understanding that engineering effort that it's going to take to deliver on that problem, grounding that solution in the physics. And with this clarity, that you'll be able to develop a program roadmap, your architectural plan. You'll be able to empower your team and give them clarity on what that mission, that goal, what's the path to success. And that empowers them to make autonomous decisions aligned to that goal and objective to solve the problem. And sometimes it's really important early on within a project to do what I would frame as a research and architectural study. It's really about understanding the engineering feasibility, the resourcing there. And I think for the entire program, the success of that phase 0 will really help you understand any of the key gotchas and mitigate some of that risk. And a key gotcha in this first phase here, I would say, is just because it's kind of this innovation investment study, it's really important to define the definition of done and what it's going to take for these team members to deliver on what's that common goal, scope that investment as well, even though it's an innovation study.
Fantastic. Well, and Julian, I'll come to you next. I feel like a lot of people come to Clearpath looking for complete solutions out of the box. How do you help your customers manage expectations and set that stage for them to be successful with your robot chassis?
Yeah, thanks, James. And that's true. I'm going to echo a lot of what Mitch said. We are often approached for ambitious, complex robotic development programs. Often these reflect sort of, ideas that are seen in the media or technologies that are very mature and may have tens of millions of dollars sort of poured into them. And often the best sort of first step is to sort of list all of those expectations and put those through like an initial feasibility study, really make sure that everyone at the table understands the constraints of the program, the needs in terms of requirements and functionality, and the needs in terms of safety. And it's early on in that sort of concepting phase that there's an opportunity to enable a project for success by reducing complexity in every one of those facets where possible.
Fantastic. I think all good points there. And David, coming to you, your Rocos platform addresses a really unique gap in this solution space. I've heard you comment previously that some of the best organizations your teams are working with decided not to buy the robot first, but rather they focused on the platform and software first. Can you walk us through a little bit of why this approach might be a great first step early on?
Yeah, I think as Mitch and Julian have mentioned, there is what we term the job to be done. So really clearly defining what is that job that you're trying to do. And the question is, how does that integrate with the people and other systems around it? We talk about really capable robots are like hiring a really great employee. But if you haven't got the systems and processes around that employee to give them the work, monitor that they have everything they need, be able to jump in if things aren't going to plan, then you can't get to what we're focused on, which is scale and full autonomy. Many companies have this 5 to 10 year vision on fully automating many areas of their business. And in order to do that, these robots have to be able to integrate with existing software enterprise systems. They have to integrate with the humans that are working in these projects. You need very clear monitoring strategies in that process. So just like the team, we work heavily on expectation management. What are they trying to achieve over what time frame? Reducing the complexity. But for us, it's also identifying those peripheral systems so that when the robots are performing, which is no small task, the teams are working really hard to make sure the robots are performing, but it's about making sure that they practically integrate. And then for us, it's starting to free them for that full autonomy so that they're fully integrated with the business process automation.
Fantastic. And Ben, finally coming to you, robot fleets are beginning to grow larger and are now including a lot of different types of robots maybe in that fleet. Your team is focusing on arguably one of the most important areas of the technology as it relates to the overall solution architecture, which is robots need power. What are some of the key learnings you and your team have seen from the many robot integrations you've been a part of?
Yeah, thanks, James. And, I think you said it well. Robots have batteries and batteries need to be recharged and batteries eventually need to be replaced. Power is often something that doesn't get addressed till later down the road in the development of a robotic system. There's a lot of problems that have to be solved first, right? There's got to be a platform. There's got to be management for that platform. There's got to be, autonomy and sensing. And then at the end of the day, oh yeah, it needs to recharge, right? So one of the challenges that we see is that for autonomous charging in particular, there's a lot of edge cases that oftentimes don't get thought about until their experience in the field. And in some cases, based on how charging or battery systems were architected, those can be really hard problems to solve. And in some cases, you know, if you experience a battery failure at a customer, those can be deal-breaking events, right? Mm-hmm. So at WiBotic, we've maintained a high sense of focus on solving the power problem and equipping companies with tools that help them, you know, identify these edge cases related to charging, related to managing fleets of batteries. How do you deal with charging those batteries, especially for diverse fleets? How do you deal with thinking through the logistics of needing to replace batteries eventually for hundreds or thousands of different types of robots? So at WiBotic, we try to simplify it by helping companies solve the power problem.
Fantastic. And I just want to make clear for all of our panelists, you guys are, you know, sort of sharing some commonality in some of your answers. You know, if there's moments where you guys want to jump in and sort of riff off one another or, you know, respond to somebody, please feel free to do so. I want this to be just a super fluid discussion. I think we're going to touch on some interesting topics here, but sort of keep it going here a little bit. We've just spent a little bit of time
one
now.
Quick thing to add to
Go
that.
ahead. Please.
I've seen a lot of times that you have to look at where are you deploying this fleet of automation, and you physically have to plan out those paths. You have to make sure that charging station doesn't have some human device, robot, whatever, blocking those charging units.
All things that would likely come up in a phase 0, right, Mitch?
That's right.
Fantastic. So yeah, we've spent just a little time now kind of getting into some of the challenges that all of you are helping customers with, but I want to switch directions and kind of maybe get to more of the positives. You know, so the question for all of you is, you know, where are autonomous mobile systems right now actually seeing the most success? You know, what are some of these use cases? You know, what are the ones that are proving to be, you know, worth scaling with? And so, you know, maybe Clearpath and Julian, let's start with you. I think you guys have had so many robots in the fields over the years. You've likely got some really great insight on this. What could you share with us?
Yeah, it's an exciting time to be in robotics. So I think the world is pretty comfortable with deploying robots in industrial environments indoors. Like a lot of those technologies are maybe not completely mature, but reliable in an indoor setting. And there's this sort of frontier of deploying robots outdoors that we're seeing a lot of different companies just start to initiate. It's really exciting. So we would call that sort of the growth front right now. And, you know, as this seminar suggests, the most exciting applications for us, the most frequent requests for application development is in the areas of remote inspection for asset management, for sort of large equipment inspection, places like oil and gas, solar, wind farms, and chemical facilities.
Got it. And David, coming to the Rocos side, I mean, your entire product is for people who are scaling fleets of robots. Yeah, what are some of these use cases? Who are some of your customers? Not necessarily naming names, but you know, walk us through who has fleets of robots right now that are, you know, using this type of system.
Yeah, and I guess we actually do not more than 90% of our work is offshore, but New Zealand has quite a unique environment that there's a huge amount of agriculture and there's no government subsidy for agriculture, which means it's very expensive and you're very conscious of human labor. There's also global shortages of people involved, you know, things like picking fruit and that type of scenario. So there's a huge amount of development work in New Zealand in particular on full autonomy in the agriculture. And this is open environments, kiwi fruit orchards, apple orchards, these types of environments. And that could be weeding, spraying, fertilizing, increasingly getting towards picking as a much more complex task. But the other areas we see massive global demand really, one is marine, and very similar to kind of the drone space, which we also work in. Marine actually has had a lot of autonomy in the last 20 years, and it's a very open environment for boats to move around. It's highly digitized in terms of knowing where vessels are. And so boats and submarines for ocean scanning and many of those tasks, which are very expensive to put humans on the vessel, that whole area is opening up, and we're starting to see larger and larger fleets now, particularly in the marine space. And then similarly with big energy companies doing full autonomy around inspection scenarios, leaving robots in these remote environments, doing regular scans, and also available for teleoperation if they need investigation work taking place. So those types of categories are absolutely launching. And then, we see other areas just in the more kind of infant stages.
Fantastic. Ben, I want to, come to you. I think, again, your technology helps support a much wider diversity of robot use cases. I don't want to exclude drones from this conversation. So yeah, help us understand a little bit more about, what you're seeing in your world.
Yeah, we have a very broad definition of the word robot at WiBotic. Robot means drones, it means carts, it means mobile robots, and we've worked in really 4 different industries within that definition: aerial drones, mobile robots, underwater vehicles, and most recently space. We're super excited to be partnering with NASA, building some autonomous charging platforms for future lunar robots. And with all that said, we see a lot of similarities, but there's also important differences between those things. And one of the things that I thought I might highlight here is a story about kind of how one particular application evolved. We've been working with this company. They're a manufacturing company for several years now, and they have a cart. It's basically a robotic cart. It's a battery-powered cart. And for many, many years, this company's been manufacturing products for almost 100 years. For many, many years, these carts were tethered. They had a cable that would either be plugged into it or would follow it around because the cart had sensors and things that needed to be powered up. But it just became inherent to their process that every so often the cart might run over the cable and break it, or it'd come unplugged. And so it was just someone's job to go in and fix the cable. But going into this facility, this was a really harsh environment. They had conductive dust everywhere. Wasn't the safest place for people to go. Wasn't really a task that anyone liked doing. And in some cases, they had to shut down the facility for people to go in to do this task. So they sought a better solution. We asked them, how'd you find WiBotic? And they said, well, we were just searching for, autonomous charging. And so we worked with them to eliminate this physical mechanism used for charging. And one of the things that was great about, helping them eliminate this bottleneck in their process was it evolved, and they started asking questions like, okay, how can we get better insight into what the device is doing just by logging into the WiBotic charging system? So that's evolved into, we have a new product called WiBotic Commander that kind of gives you a bird's eye view into fleets of charging systems. And we look at this problem across all industries as like, in some cases, you have to learn how you should scale. You might not know how you should scale. So for a drone deployment, if you are doing a pilot with power line inspection with 1 drone to start, and then you want to go to 10 drones, and eventually you want to go to 1,000 drones, how many drones would you need? How far away would the charging stations need to be spaced? I think all these questions, we look forward to learning as much about as we hope to provide solutions for. So I think that's an important thing for us when we think about, how do we maintain this application agnostic nature, but help things scale and move forward.
Fantastic. And so I want to switch gears here just a second and, bring Mitch in. What we talk about a lot too is sort of, integration trade-offs or scalability being sort of a problem of design. walk us through, I think, some of the discussions that we have early on when it comes to scale, maybe talk a little bit about the importance of adoption here as well.
If I might, James, I want to add just a comment here to the prior conversation.
Sure.
Hearing a lot about these different, sets of stacks and focus areas, I think it's really about going back to clearly understanding what's that problem we're trying to solve. And then it's that entire integration. It's these others that we have on the webinar and other technology stacks. And it's not just about assembling them, but connecting them in a way that truly solves that problem for whatever that growth area is. So that we're ultimately delivering value to that end customer. And so I think that comes back to the scale and how do you look at scale. It starts with understanding where you're at within the scope of that problem, and when what's your goal? Is your goal to develop a prototype, or is it an end production at an overall fleet management? And then you can work back into things like trade-offs on reliability, things like how do I prioritize my engineering efforts? Looking at RPNs, risk priority numbers, and tailoring those investments. And when I think about that problem of scale, it's about how do I make sure that whatever I'm working on right now, when it's deployed to that customer, it's much more difficult to fix that when it's in the field. The cost of fixing is significantly higher. So then it's look at that feeds kind of back into reliability. How am I doing those reliability trade-offs? What's okay if my deployment or my problem I'm trying to solve right now within the program phase is just I'm doing a one-off prototype and I know the team is going to be able to go on site with that customer and kind of work through things. That's a different type of development effort versus we're deploying thousands of these robots and we can't touch them and we have to train that customer's team to be able to do the field maintenance support.
Yeah, I'd like to add to that.
Please, yeah, absolutely.
We kind of have these two curves that's happened is when you're building robots, especially in PhD land, getting robots to not fall over. What happens over time is you move closer and closer to field trials and production, and this technical capability to deal with these variety of robotic issues, including battery problems. Your capability of robotic troubleshooting starts to go down the further into production you get and the further you scale. But in the reverse, the domain knowledge goes up. So the people in the field working with the robots in these domain environments is going up and up and up. So they're really practical about what they really want the robot to do versus the original mechatronics person who kind of thought the robot should do it in a specific way. And so what we find with scaling, you've got this problem of less and less people able to troubleshoot. So you really have to make the robots as reliable and simple, just simple things like the recharging problem. You can't expect people to take the battery out and have this long list checklist that they need to go through. It really has to be as automated as possible. But the flip side is you want to feed back to the roboticists that field expertise so that the roboticists are becoming domain experts in the field. And it's no different to the software industry. Is a great example. You take something simple like McDonald's globally has this program for suppliers where they take the suppliers and they get them to work in a store for a day, a year. You might be the CEO of somebody that provides cutlery, and it's like, come into our store and see what we actually do, because it's totally going to change how you work with us. And so for our mechatronics teams, it's go into those environments and get saturated with that domain knowledge, because it will absolutely change the shape of how you do things with the robotics. And to Mitch's, phase zero, that's where you kind of meet contact with the real world, and if things are really going to be practical.
And Julian, I think all of this funnels perfectly back to something that Clearpath almost lives exclusively within, which is, the reliability. I mean, you are arguably the provider of foundational hardware in most of these equations. If the robots can't work when people need it to work, if it can't meet some of those uptime requirements, where do they go now? And so, yeah, maybe kind of take us home on this topic a little bit.
So a useful framework we use when talking with new clients about sort of the state of their project is the technology readiness level, and anyone can sort of Google TRL level. It's a wonderful way of sort of communicating where you expect your robot, how reliable you expect it to be, whether it's going to be fully commercially deployed without any sort of like intervention, or it's going to be a supervised sort of application. And I think the most important thing for clients to understand is that the steps through sort of supervised application to semi-supervised to like final iteration are not iterative in terms of the effort they take to deploy. They're exponential. And I think that, so everybody's been touching on the same point. It takes more and more effort to sort of bring out those final few percentage points of reliability. And it's important to keep the system as sort of like incomplex as possible and use as many validated systems as possible to make that process faster and cheaper.
Fantastic. I'm going to sort of, or Ben, go ahead if you've got a comment.
Yeah, James, I was just going to add one different element to this quickly. I think one thing that has probably impacted all of us here, at least in some discussions, is the evolution of standards and regulations for robotics, right? Yeah. It's a new thing, but for applications that require safety standards or are subjected to certain regulatory standards because of where and how the robots are going to be used. Right. Those are some big challenges, and a lot of those things are ever changing. At WiBotic, we've tried to we've understood what the requirements for our products are, and we've worked to meet those requirements. But then, if our product's going to be used inside of a larger ecosystem of a robot, what challenges is that going to extend onto the robot company or the end user? I think that's an important topic, going back to thinking about cohesion and how we all work together. It sort of is, those standards are always one of those things that seem like it's far away and it's not going to impact you, and then eventually someone asks about it on a call and it becomes the top priority. Right. So I think that's a topic that is important to think about in the context of reliability as well.
Yeah, and
yeah, go ahead.
Sorry, one thing we focus on around this human supervision side of things is how do you potentially still give access to experts to the robots from that remote location? So right. Obviously that's a heavy area that we focus on at Rocos, is to say, yes, of course, we're trying to do full autonomy. We're trying to integrate it with systems so that it's only management by exception in rare scenarios. But it needs to come all the way back to, can the mechatronics engineer get access to the command line? Can they get access to a really big log file when they need it? Can they update the software? Can they teleoperate the robot under a scenario where it got lost? Which means you get much closer to getting your robot further and further into the field, and you get those domain learnings faster, even though you have a remote team that is doing intervention. There's a great customer we have that works in the pick and place industry, and they'll have human supervisors where your robot only has to be 95% effective, and the human supervisor can help train the robot remotely to pick the different shaped parcels and those types of scenarios. So that's a perfect scenario where you could never put that robot into a scenario if you're expecting it to get 100% correct. But now that robot is actually immediately valuable, and you've immediately reduced the cost of the scenario, but you still have human supervisors full time from a remote location helping out.
Oh, all fantastic points. Julian, I want to sort of bring you in here because I think Ben touched on something that's pretty important to you in Clearpath, which is, certifications, regulatory issues, things that prevent robots from going into certain places. I know our teams are members of the Sprint Robotics organization. I immediately think of ATEX and, class 1, div 1 environments and places where, hardware is just not allowed robots to go successfully. And then to, David's point, where there's this requirement for remote operability and sort of, human eyes on these scenarios. What are some of the conversations you guys are having around this, and kind of where is maybe Clearpath trying to head to, create more opportunities for robots to work successfully in these environments that require these certifications?
So I'll start by seconding what Ben said. It is a dynamic environment, the regulatory environment. It does not just vary from geography to geography, but also from application from application. So if you're doing something in oil and gas, you might have to comply with a different set of standards than might apply to an entertainment application. And so it's important to include this in your initial sort of phase 0 concepting plan. And if possible, partner early with the sort of certifying body that might be involved, understand their process. Likely as not, for really new novel applications, the outcome of that safety review and that safety process, the certification process, because they're often one and the same, that's going to drive the design. And so it's important to not be caught off guard by having to consider that at the end of a project.
Yeah. And Mitch, bringing you in, I know something our teams do is, help people scale up. We've, got the ability to sort of bring people into the manufacturing side of, their product development. All of these certifications, tie into, these sort of phase 0 approaches, these design thinkings. Help us understand sort of what some of those requirements do that impact the manufacturing side of these robots. It's one thing to impose these restrictions on robots. It's another thing for a robot company or somebody who's trying to build these robots to actually fulfill on that. A lot of these have really real expenses and sort of annual sort of recertifications tied to that. I'm wondering if you could just maybe add some color and context there.
When I think about that question, I think about the design and what that operation environment that robot's in. So there's the safety standards, etc. But then there's also not only the core, I would say the robot user or operators, but then there's this element of in the hybrid deployments, who is going to use this robot? Like who's going to be walking around it? Is this robot conducting an autonomous mission alongside some type of other human-driven electric vehicle? And if that robot gets in their way, are they just going to bump the robot out of their path because they have to get through? And then so all of those considerations come into, well, do I have bumpers on my robot? Things like that.
Yeah, I think
we're
on our side.
Go ahead.
Sorry, on our side too, we try help companies, especially on the software and cloud certification side of things, where people are saying, we've got medical robots, we need HIPAA compliance for the data that we're dealing with, or we have specific security requirements. Is there SOC 2 compliance? So without the teams having to go through that process themselves with the software, we can deliver that type of capability off the shelf from day one in these scenarios. And it's not always that easy, because sometimes you can say, well, hey, we don't need that certification as long as we're not storing this type of data. But if you look at video feeds, classic example, there's personal data on video feeds, there's people's faces getting streamed. So how do you either avoid that, don't do that, or abstract? You have all of these choices to make. And one of the biggest questions a lot of big enterprises have is still on-prem software deployment versus cloud deployment. And having worked in many previous generations, you look at things like the banking industry that now is embracing cloud and actually moving to the big cloud providers with their very sensitive personal data and banking data. Robotics project is a huge amount of sensitivity for utilities companies. It's a national infrastructure. So do they deploy on-prem or cloud? So there's a whole, once you've solved the physical requirements for robotics and safety, you've got that next set of digital standards that you have to meet, which is just a whole nother layer of complexity.
Yeah. We're starting to get into some really interesting topics about safety. I want to kind of deviate here for just a second. I'm seeing from our colleague Anna that we're starting to get some really good questions coming in from the field. This is kind of maybe for, maybe mostly Rocos and Julian and Mitch, but, let's talk about sort of the implications for AI, deep learning, reinforcement learning, as it pertains to localization, mapping, and navigation. When we talk about reliability, when we talk about scalability, when we talk about robots being able to thrive in unsupervised environments on their own, there may be, points where, they need to make transitions from indoor to outdoor. There may be GPS denied environments. Mitch, maybe sort of kick us off here. Introduce this sort of, come to us with this topic of sort of where AI and reinforcement learning maybe fits into this equation for mapping.
Yeah, I start to think about things like, your computational graph and what are all the different, control problems that you have as it relates to, solving that customer's problem. And not just the operational control problems, but when you look at that, make buy analysis of what different tech is out there in the industry and filling those gaps, you start to identify, things like, going from that outdoor to indoor threshold, you have to light up a whole new sensor stack. And so looking at, well, what sensors are on board that I could still rely on. So things like, well, what if I, have through that latent space a IMU only base nav? So I know I'm about to go in, and then that can help me carry me through that threshold, so that then I can find some type of localization target inside that building, et cetera. And
Julian,
I think that it's about.
Or yeah, go ahead.
The one thing is AI is this huge space. It's evolving, and there's different theories and models and approaches. And that's where I kind of going back to that computational graph is like, of these, engineering physics problems, what's the best one for that? And then build there. Don't just try to go, I'm doing AI and it's going to solve all my problems. Well, focus that effort.
Got it. Julian, I think that segues perfect to, what your platforms have to continually think of, just sort of continue on from where Mitch left off.
Yeah, so this is often what our clients are integrating on top of our platforms, right? So it's the solutions they're implementing, and some oftentimes, with a solution like Rocos, on top of all the basic sort of controllers and sensors we're installing. From our point of view, and this is changing quick, what we're talking about here, the moving from indoor to outdoor applications, that's the bleeding edge of sort of navigation technology right now. So if we consider like indoor navigation a fairly solved problem, outdoor sort of not quite yet, then transitioning intelligently from one to the other and dealing with all the edge cases associated with that is pretty challenging. Add to that the fact that machine learning driven navigation, like vision-based navigation, has some inherent sort of limitations in terms of reliability, right? Like it can only be so reliable. And it can be very reliable, sort of like 97 or 98% reliable, but that's just not probably good enough for most applications.
Yeah, I mean,
in that architecture, what's the rollback plan? When you have a vision-based nav, what's the failback? How do you know that there's been a failure mode that's occurred, and how do I recover from that? Relocalize maybe through a behavioral engine, et cetera, state machine.
Yeah, I think that's where David comes in, right? Exactly.
Yeah, the challenges go further than that. So for us, I think all of us just wish this was a solved problem where you could buy that magic black box that just knows where the robot is. And we talk about the scenarios, especially when a robot wakes up. So we love wireless charging stations, because when robots wake up, ideally they're waking up where they went to sleep, whereas sometimes they go to sleep where they shouldn't, and when they wake up, they don't know where they are. But we have one step further, which we focus a lot on digital twin technology, where an operator can design a mission in a 3D environment. So the robot really has to be able to transition from GPS to an indoor localization system and find its way around that environment. And the problem with that as well is, if you have people starting to introduce things like AR, where in AR, in the physical environment, you could actually plot the mission for the robot. How do you do localization of whatever the augmented reality devices? So guys like Microsoft are doing great work around, geospatial anchors, where the robot and the human and the VR, all of these systems can share a common global anchor. So that's even further into the challenge of how do they all share this. I think the good news is there's so much promise from all these various sensor companies, but I think the challenge from an expectation perspective is it's just not there yet. You just can't buy that magic black box yet that can just do this all. So, I'm personally hopeful that we're only a few years away from a cost-effective, really great solution for that.
And Ben, I want to bring you in here. Yeah, please.
Yeah, I thought I'd just share one kind of specific example that I think brings a lot of what Mitch and Julian and David are talking about, but it's drone related. Construction is maybe arguably the biggest industry user of drones in the commercial sector. And a lot of the use of drones over the last several years has been a construction company would hire a service provider to bring a pilot out, fly a drone. That person would go back home, download the data, perform analytics on it, and provide back a great stitched image of whatever the construction company was interested in seeing. It's been so good, in fact, that the construction companies, want to do this more frequently. They want to do it on a daily basis now, and use it to track other things on the site, personnel safety and lots of other things. But to achieve that is really hard, because now you need a charging platform on the construction site. You also need precision landing of the drone to be able to land super accurately and reliably. You need, the onboard, the local compute, because construction sites don't always have all the energy and connectivity infrastructure, since they're still being developed. And so as we kind of think about our piece in this evolution, and helping to enable that, it's really interesting, hearing everyone talk. I think each of those problems I mentioned is like, there are multiple companies trying to solve just those one problems. So how do technology companies help the construction industry, achieve this, right? Well, we know that they probably don't want to become drone experts, nor do they want to own technologies, because then it's just another asset on the site that they're solely responsible for managing. They'd love to just log in and download, this report as often as they wanted to. So I think about, Fresh Consulting's role in this ecosystem as, service provider, system integrator, understanding how all these pieces go together. About, David's piece of being able to manage diagnostics remotely and having digital twins for drones, I think is super useful too, because there's a lot of risk that can happen if you lose the location of where you think the drone is.
Right.
So it's an interesting concept of like how I think, AI probably touches each of those elements, but how you apply it to solve a specific problem is important to think through,
I think the great thing, as you're saying, is there are these third-party providers that are absolutely specializing in these unique areas. And for us, the more specific machine learning capability is there's actually a lot of great machine learning out there. A simple example might be to convert an analog gauge to a digital reading. And so you've got, a company like Fresh who may say, hey, we've got a solution to a machine learning capability, but then how do you get that, the ability to send the sensor, which could be any number of sensors on any day, how do you get that image to the machine learning? So for us, we're again focused on platforming that so that you can build a skill with AI machine learning and deploy it where you need it. And that may not be the cloud. So obviously a lot of our work happens in the cloud, but what we want to do is to say that robot, when it's on its mission, needs to be able to operate autonomously. So how do we help companies get the machine learning to the robot with a non-expert user? You don't want a DevOps manager having to deploy things in the background. You want an operator to decide, today I want to get the robot to go here, take a photo of that gauge, convert it to digital, and then decide if that's a good thing or not. And that should happen for a non-expert user. So for us, platforming machine learning is a really important part of what we're trying to do around giving robots skills, but those skills need to be able to come from any third party, so people can build this library of skills.
And to build off that, when I look at AI, I think there's a lot of promise in that. When I think about autonomous systems, it's about, breaking up that control problem into my states, terminations, action, rewards, maybe for an RL type of application. And, like Dave was saying, when you apply a digital twin into that and you simulate it, contrary to having a physical robot and simulating, that physical robot's a one-for-one test. But you bring that into a virtual environment, you can train a model at scale in parallel. Took 20,000 simulations running across that to optimize that one component of your control.
So I think we could probably land on this topic for quite some time. I want to continue to maybe sort of drip in some questions from the audience, because I think we're starting to see some really good ones. I'm going to try to sort of blend two questions here together, because I think they're very related. Is, one which is, what is this sort of relative ROI threshold that sort of gives that green light for production level to move forward with scaling a project? And I think something that's kind of relevant to all of you here is the follow-up is that what is the strategy to then scale from a pilot in sort of maybe 1 to 2 facilities with maybe a few robots to several hundred? So talk to us about what some of those thresholds are. A lot of them require different implications for things that need to be imposed in the environment as far as infrastructure. So yeah, help us understand for some of our listeners, what are some of those key ROI thresholds, and what's the strategy for scaling progressively from a few to 100?
When I think about
anyone
this
can
problem,
sort of take that.
Yeah, when I think about this problem, I go back to that kind of phase 0, and ROI thresholds I think are environment specific, they're company specific, they're operation specific. A lot of times that maybe there's some type of failure mode in that operation, and this autonomy is supplanting that. The end goal is improving the customer sentiment of that product through a logistical thing where there's some type of backlog in those operations, and this automation comes in and improves that, some type of queuing within a critical point of that logistical flow. And it's then you start to ask things like, well, what is the cost of losing that customer? What's the cost of a sale? And then I think it's the other thing when I think about ROI is think about those other things that it affects. I think you briefly mentioned the infrastructure cost. It's not just the robot, but it's the how are other people going to not only just the installation cost of infrastructure, but how does that impact other users in that kind of hybrid environment where there's still human operators and these autonomy solutions?
Awesome.
Yeah, I think the one
Julian,
great example
David,
is this phenomenal company in Silicon Valley, FarmWise, that focus on mechanical weeding, especially in lettuce fields and things like that. And it was fantastic talking to their CEO around the fact that it's very difficult in the very early days to potentially predict fully what the ROI of some of these systems are until you've actually gone deeper into the domain, because their great example is, because you're doing mechanical weeding, you don't have to necessarily spray. So you're starting to get into this ability to become more organic. And then the question is, because you're not spraying with very specific sprays, you don't necessarily have to buy the seeds that are spray resistant. So you're going all the way back to, you're actually transforming the types of seeds you can purchase, the way that you can actually transform to organic, so you have a higher value product at the end of the day. It's not just the simple, how much cost saving and labor, am I reducing? So I think it's important from an economics perspective, as much as there's so many other factors that you need to take into effect. The other thing I'll say is that there's no doubt that there has to be some form of belief that the sensors cost will come down, the robots cost will come down, the AI will get better ultimately. So I think there's less sensitivity towards, am I going to get my money back in a year? And it's more a question of, if I don't implement physical automation in my business, somebody else will, and my company will be a dinosaur in 10 years time. And we're seeing a lot of that, the desire for optimization, the desire for an ROI, but it's also that incredible competitive threat that if I don't, all those companies that Netflix left behind doing DVD rental, it really is that scenario if you're not doing physical automation.
Yeah.
That's an interesting point.
Go ahead, Julian.
Yeah, so just to touch on what David said, yeah, when we're talking to clients about sort of what their final solution's gonna sort of look like in terms of costs, we do have to talk about this sort of continuing trend of like a reduction of cost of sensors. So there's been hundreds of millions of dollars poured into the development of autonomous vehicles that has really driven this, all these new companies developing lower and lower cost sensors. In a lot of cases, like by an order of magnitude, specifically in the LiDAR space, but also with machine vision. And so it's there is an expectation that the cost of those sensors will be 10 times lower again in 3 to 5 years. And then just to build up. Go ahead,
Mitch. If I can, I want to bring Ben in here too, because I think WiBotic might have a really unique perspective on this sort of bigger question of sort of scaling from 1 site to 2 sites to 100. As we see a lot of industrial complexes, taking their forklifts and other, AMRs and, going electric, getting wireless charging is a big infrastructure overhaul as you start to look at, 100 locations. I'm wondering sort of how you've been sort of thinking through those implications with your customers as they look to that.
Yeah, obviously it's been interesting for us because I think we're in some cases 1 step removed from, the end user's ability to really drive efficiency. But where we've really focused is around the power piece. And what we've actually shown is that there is quite a bit of cost, efficiency, and operational intervention savings that you get if you really think through and optimize power. And so, for example, let's say a company has 100 robots, right? Well, undoubtedly, at any moment in time, a certain number of those robots are going to have to be charging. But how many charging stations do you need to support 100 robots? Well, a lot of that answer depends. It depends on what's the power consumption of the robot when it's operating, which impacts how long the battery can last before it comes back to recharge. It depends on whether the application has a nighttime where the robots can just be spending all their time charging, or is it a 24/7 operation where just fast charging and getting the robots back into use is the most important thing. And so one of the interesting things that we've paid attention to is, utilization of the charging station and frequency of charging, right? Wireless charging is great for what we call opportunity charging, where a robot might be going back to the charging station much more frequently than it would otherwise. If the robot has 5 minutes spare just to sit there and do nothing, well, go back to the charging station and charge. And with a contact-based system, the number of connecting cycles would become very high, and those connectors might have reliability issues down the road. So some of the metrics, those are some of the things we've paid attention to, and we've shown some of this is simulation, but some of this is from fleets of tens where we've actually been able to get some of this data, that by really thinking through charging schemes, charging station locations, you can save as much as 10 to 15%. You can increase the uptime of a robot fleet by as much as 10 to 15%, just by doing some simple things. It's not like a whole hardware software stack change. It's just rethinking the way that you instruct robots to do a task. And we hope that leads to more cost savings. And again, just part of it is you learn as you go. So
I want to jump in here. We've got about 7 minutes left. I think we could probably spill over a little bit. I want to see if we can get sort of 2 kind of bigger picture questions in here. We've had a couple come in around sort of how do you all approach a robot operating in an unreliable network or sort of low bandwidth network. There was another question around sort of how far are we from adopting 5G support in the robotics industry. I think that's very related. And then there was another question that I think is also very intertwined here, which is, transitioning from indoor to outdoor is bleeding edge, but, is there a market for this as well? I would personally agree with yes, but so I'll kind of throw that, sort of 3, sets of questions, to all of you real quick. And then, after that, let's see if we can maybe sort of wrap up with one more topic.
I'm happy to kick off. We obviously have a lot of processing happening in the cloud or on a server somewhere. So everyone's like, well, are you expecting full-time connectivity? And the answer is absolutely not. We've got customers with full 5G implementations with, moving containers around. And as soon as you get a container between you and the 5G tower, you've lost your connection. So everything you build has to assume constant breakage and connection. And we talk about like the traditional IoT sensor, you know, on the fridge. A fridge is either well connected or it's just not connected. Whereas with robots, they're badly connected a lot of the time. So packet loss, and, you know, I think I've almost got my connection to the server. So you have to have an incredibly resilient onboard software stack. And so our team, we have two completely separate teams. We've got the cloud team building server application, and then we've got the mechatronics team building the onboard software. And that onboard software for the robotics teams that we work with, you know, when a Fresh or a Clearpath are talking to our robot local software, they have to basically treat that as 100% reliable. And we then have to make sure that the network is not their problem ultimately. So we need to make sure of the reliability. And a lot of our tech was actually built on a DARPA subterranean challenge where these robots are underground. They've got really weird network environments. They have to communicate locally and they're constantly being disconnected. Our marine customers have submarines and boats, and, you know, we've got drones out there, and all of these are just constantly having problems with network connectivity. So it's a big problem. And, you know, what we're trying to do is abstract that for the mechatronics teams to say, you can rely on talking locally like you would with a ROS implementation, but then what we try to do is basically fill that gap on making sure things get through or being very clear that things haven't gotten through.
And I would argue that some of the best robot use cases right now for mobile systems are in those environments where connectivity is, you know, the least stable. And so, yeah, Mitch, you know, maybe sort of pick up your point.
It goes back to those really understanding your requirements, and, you know, in a dark zone, that threshold between them, what does your overall operation need? Does it need the most up-to-date set of data from a, you know, operation nav telemetry standpoint, or does it just, you know, and maybe less of priority, it needs all of the historical data, but not in priority. So then it goes back to your software architecture, and that from a data structure standpoint, do you implement a storage queue or do you have a stack? And you know, what data do I prioritize sending when I do have that connectivity in an intermittent state?
So I want to make sure we're sort of answering a couple of the key questions here. One of them was, you know, how far are we from adopting 5G? And I think, you know, the reality is 5G going to be the right path to go down to actually address some of these issues? Are we there yet? Maybe just a quick, somebody answer that real quickly.
So from our standpoint, we go to a lot of academic robotic conferences. 5G is sort of one of the leading topics of development. So researchers are understanding that this is a game-changing technology because it's going to increase the reliability and the bandwidth of communications a lot. It's going to change how easy it is to do robotics. But, you know, that can only happen as fast as the networks are sort of commercially available, and it still seems like it's some way off. And then, you know, after that, we're going to have to build out the commercial solutions that are going to go along with those networks.
Yeah.
So it's a few years.
Yeah, and I think it comes down to location and distance. We've got the America's Cup happening literally, 300 meters from our office here, where you have these incredible yachts out there that are full 5G connection. They've got streaming telemetry coming live off the boats to their HQ environments. But that environment was purpose set up with 5G. And I think that's the thing people are missing at the moment is 5G is not just suddenly available in 98% of the country. It's really very small pockets, and it's very low range. So when you're in agri-tech environments, you need something that can go, 20 miles. You don't need something that can go, half a kilometer or something like that.
So we got basically just a minute here. Mitch, sorry, I don't mean to keep cutting you off. I just want to be sort of conscious of time.
Real quick, I just want to, agree with both Julie and David, and then just offer that if connectivity is really a hard requirement, there's more and more LEO-based connectivity companies, these days.
LEO, for everyone, low Earth orbit is kind of what you're referring to there?
Yeah, and exactly. And so it really just it goes back to where's my location of deployment, and looking at those requirements of connectivity and what's available from an infrastructure standpoint.
Yeah. So it looks like we've got, a few people starting to drop off just due to time. I want to maybe sort of, close things out with sort of one last question. Building off of everything that we've talked about today, where are there still some gaps in the solution space that we've been talking about? Ben, David, your companies were founded because of really, sophisticated gaps that you guys saw, not being solved. Maybe let's just kind of go down the line. Maybe there's some budding entrepreneurs on the call today who might want to start trying to build companies to solve these things. But where does this group here still see some gaps that are preventing robots from living in these environments on their own, being sustainable, and really fulfilling at tasks at scale? Let's maybe sort of bring it on home with all of that.
Really quick one for me, a +1 on the indoor navigation and capturing 3D environments indoors. Talk to us if you've got a great solution for that.
Yeah, from our perspective, maybe I'll share less of a technical thing and more of a process thing, but we have a lot of insight, and we track, kind of the evolution of our customers, because some of them might be big companies in a very early stage of development. Others might be startups who have deployed a lot of robots. By far, the bottleneck that's biggest is companies who are doing pilots. So they actively have, a robot that's working. It might even be deployed on a customer site, and going from, 1 to like 10. That step is seemingly so hard. And I think a lot of what we see, and we're just kind of a third eye into this, but I think what we see is that it just really comes down to scope creep. Things start to, like, it does 98% of what they want it to do, but this one thing it doesn't do super well, and so they will change it, and that just kind of can go on for years.
Yeah.
So for us, I think that kind of is the area that we want to focus ourselves, and just say, what can we do to help make sure that our products can get these to that 10s, and then from there, things are pretty well locked in. If it's working at 10s, it's pretty easy to go from there to a lot more.
Fantastic. Maybe Julian, your closing comment here on sort of what's the sort of big gap that maybe Clearpath is going after?
Sure. The frontiers of development for us seem to be sort of reliable, safe outdoor navigation. That's still sort of, in every environment and interacting with people.
Lots to perfect there for sure. Absolutely.
Yeah.
Mitch?
Yeah, building off Julian, I would say, look at what are those known solved problems in other industries or verticals, and how they're not yet solved for robotics applications. So I think about, when I put in I'm traveling somewhere, there's an app that, tells me the road I should drive on, and if there's an accident, a next best route. Like taking that known solved problem and applying it into navigation within robotics.
Fantastic. Well, so we're just a few minutes over the hour here. This has been fantastic, guys. I think what brought us all here is that we all mutually agree that robotic success in the field doesn't exist in a silo. It takes partners. It takes industry collaboration. I think we're all, one of my favorite things about working in the robotic space is just how much sort of friendly, competitive nature is, sort of competitiveness is out there. Success for one of us is often success for many of us. We're all still trying to prove the viability of a lot of these solutions. And so, I would certainly hope to see a lot more of these types of discussions, from, players in the ecosystem coming together, showing how, people can scale well and work well together. So this has been a fantastic discussion. I hope everyone who's been listening has seen a lot of value from this. Again, I think our group's going to try to distill a lot of this discussion into, kind of a white paper that can, be something that, everyone can have access to moving on from here. But thank you all again. It's been a pleasure having you. It's been a privilege to be able to work with a lot of you guys over the last few years. So with that, I think we'll sort of cap it off here for today. I imagine there could be a follow-up to come not too long from now. So thank you, everyone. And yeah, have a great weekend.
Thanks, James.
Thanks, James.
Appreciate it.
Thanks, everybody.
Thanks, everyone.